Hi class, it's Bill Berry here with another lesson in our week 3 of our Java 2 class. And this week we're finally starting in on our data structures. We're going to start with the array list, and we're going to move on to other exciting things as we go through the quarter. But array list is a great start for us. It's something that you're familiar with probably from previous courses, and it's a good thing to demystify and figure out how to write ourselves. So let's jump to that point and get started. So when we're writing the array list, the first thing we're going to do is we're going to start by working with primitives. There's enough for us to learn when it comes to getting started with this that it's better not to start worrying about the other kinds of types that we might introduce later. So we won't worry about that flexibility for the moment. Let's just say that we were wanting to write one that works with integers, and then we'll move on. So what are some of the considerations that we're going to have to pay attention to? First of all, when we are starting here, we need to start thinking first about capacity versus size. And the important thing that we're going to see here is that when you're working with an array, of course we have a fixed size. Remember that an array is going to underlie everything that we do here, but arrays have a fixed size. But array lists seem to do magic in that they seem to not require that. Well, of course they do. So we are going to introduce the capacity versus size concept. The capacity is what the actual array is, right? That's what the array can hold, whereas size is how many items we are keeping track of now. So when we talk to our clients, we are always communicating in size. But under the hood, we have to keep track of, in fact, we have to know about the capacity. It's not something that the client code has to know about at all. So that's an important thing that we're going to deal with. Now, what kind of methods are we going to want? Well, of course, you've used ArrayList before, so you know some of the typical things that you want to do. You want to be able to add values, which will typically go at the end of the array. We want to be able to add at a specific index, remove them at a specific index, get the size, get and set things, etc. So all of those things are pretty standard in terms of what kinds of methods we're going to want in a list, or especially in an array list. So one of the questions that we have is, well, how can we implement them all and implement them in with the signatures that we would want? Well, as you've learned recently, array lists, or excuse me, interfaces are really good for that kind of thing. So I went and grabbed a bunch of the methods that we typically want to have. You can go to the list interface and you can just go and grab and do some shopping, right? And say, we don't want to necessarily implement all of the ones that they have, so this is a subset, but it's a pretty good subset. But if we start with the fact that we're going to put these all in an interface, then we know pretty darn sure that we're going to get them all done, because if we implement them, we have to do the whole set. So that's going to be a great starting point for us, is that we are going to first come into our empty array list code here, and we're going to say that we want to implement, and we want to implement that, and then of course that commits us to a whole bunch of work. And so the next thing I'm going to do is I'm going to go copy over everything that's in that interface so that I'll have all the signatures, right? So copy all those and paste them all in here, and I'm going to put those under the methods. Okay, so under public methods, I'm going to paste those things, and then I'm going to comment them all out. Notice that our selection is odd at the moment. So I can comment those all out, and then I can go add stubs for each of them as I go, so that I'll make sure that I'm ready. So for the moment, I'm going to go stub those so that you don't have to sit and watch me type them all. So let me do that, and I'll come right back. So as you've seen, I've just taken each of those methods from the interface, and I've just made them each into a stub, right? If they have a return type, I just return something, right? Return false, return 0, whatever. So right now I'm just stubbing them so that the thing will compile. I can actually go and start writing main code. I could start writing test code if I were doing test-driven development. So there's good reason to do stubbing, but we're just doing it so that we can have a good work list, and I've just sort of snagged all of the names and signatures from the interface to make life easier to get started. So that's a great place to start. Now, how are we going to implement this idea of capacity, and what are we going to do for our constructors? Like, we have a lot of interesting things to think about. So let's jump back over to the slides, and let's see what else we want to ponder here. All right, so one of the things that we're going to have to deal with is the magic of array lists. What if we run out of space? How are we going to know that that's happened? When are we going to deal with that? right? How many constructors do we have? What kind of preconditions? We have a lot of stuff before we get to iterator, so let's not even worry about that. Let's talk about the constructors first. So let's jump back over to our code and let's see what we're going to do here, right? When somebody just says make a new array list, they're going to say ArrayIntList. They're going to typically say they just want a new list, but we have to create an array of integers, right? So obviously we're going to have an array for that. That's going to have to be up here in instance data, right? So I'm going to say private int array, and I'm going to call it element data. Notice I don't want to instantiate it here. I don't want to actually bind here. I'm going to do all of that in constructor code, not in global space. And so here I have to create the array. So element data equals new int, but what am I going to put in there? Right, I have to put something in those brackets. Now, what the array list does is it picks a default value. Right, so over here in the constants, we're going to create some sort of default value, private static final int, and we're going to create something like default capacity. And we're going to just make a guess. We're just going to say it's 100. Right, so we could pick anything we want, but in this case we're just going to say, hey, the default capacity, if they just say make a new array int list, we're just going to do that, right? We're just going to pick that. So that's the way that the array list does it, is it just makes it up, right? It just has a number and it uses that number. So that's great. Now, the other thing that's interesting is that very typically we have a second constructor, right? And you'll see this, you may not have seen it on the array list, you may not have used it, but there actually is another one where you get to specify the initial capacity. Right? What's the initial capacity that you want it to have? So in this case, you can do element data equals new int, and then you can specify the initial capacity, right? You can actually do that. Now, one of the things you might want to do is check to make sure that that's not a stupid value, right? If it's a stupid value, that's going to fail and it's going to blow up, and maybe the message that you get is probably okay, right, from Java. So I don't know that we need a precondition. We could think about that. But of course, you see now we've duplicated code between the two constructors, and we don't want to do that. So how can we solve it? Well, we can just get clever and we can call the other constructor from here, right? So that we don't actually have any duplicated code at all, right? And that solves our problem, and that compiles and everything's great. But one of the other things that we want to think about right away is this idea of capacity versus size. The clients don't understand and can't really see. They have no visibility into this idea of the fact that we have a capacity versus a size. To them, we're just managing everything to deal with the size that they ask us for. But we're going to need to handle that, right? Capacity is handled by the length of the array. We don't need a variable for that, but we do need a private variable called size, right? Doesn't have to be called that, but let's call it that. And so anytime we do this, we're also going to set size to what? 0. Why 0? Because we are so far not managing any data for them, right? Even though we have capacity to manage data, they haven't asked us to manage any data, they haven't given us any data, and they can't through the constructor. So right now we're going to say, hey, we've got 0 items for you. So right off the bat, if they ask us for the size, we're going to simply say 0. So in fact, why don't we fill in size while we're here, right? Fill in the size. What are we going to return if they ask us what the size is? We're going to return size, all right? That's it. So that's pretty easy. Now, keep in mind what is going to be in here at this moment, right? What's going to be in this array? If you've forgotten what Java does, this would be a good moment to, put a breakpoint here and stop and see. But remember that when you create an array, Java is going to fill it in with 0 or 0 equivalent values. So this array is full of zeros. Now you might think that that will cause us a problem, because how are we going to know the difference between a 0 that they gave us and the 0 that the array that the Java code put there anyway? Well, this is how we're going to know, right? Because if we're managing a 0 for them, that will be included in size. If we're not managing it, if it's beyond the point where we're managing, we don't care. Right, so it doesn't actually matter that this is full of zeros. We're not going to look at them anyway if they're past the point in the array that that we're managing. So that is a good start. All right, so take a look at that code so far, and if you have any questions, of course, if you're in class, of course, you can email me. Otherwise, you can put comments down below. So that is a great start, but now we need to do something with this, right? We need to do something with all these elements that people start asking us to add. In fact, let's go over. We don't need this anymore, so we'll close that guy. But let's go over and start actually writing some main code, right? Because we need to be able to do that so that we can illustrate the fact that our ArrayIntList is working. ArrayIntList equals new ArrayIntList. Now we could tell it, right? We could say, hey, we only want 5 items or 10, but let's just leave it for the moment. And then let's go and say I want to add. I'm going to add a 3, and then my ints.add. I'm going to add a 4, whatever, right? I can go and add some values. All right, and then you notice since I have stubs, I can actually go and deal with, like writing code. I can go print them out and stuff like that, like how many you got. System.out.println size equals plus my ints.size, right? So I can ask it, hey, how many things you got? And we could start writing a loop to go through and print the things too. Well, of course, we don't have code for it yet, but that's okay. Let's go ahead and clear the screen while we're thinking about it. All right, good. So we can actually get main going even though it doesn't work quite yet. Now add turns out to be an incredibly easy thing to write, right? Add is incredibly easy. Now, it's incredibly easy as long as we don't worry about running out of room, right? So we know that we're going to have some way to know that we're running out of room, and when is the right moment to check that? Well, the right moment to check that is when we're getting in new data, right? At the point that we're trying to add something, we need to make sure that we have room for that. So we are going to come and make a placeholder for ourselves later. We're going to create a method that's going to do the magic for us, and we're going to call it something like ensure capacity, where we are going to tell it what the desired capacity is. Right? We tell it what the desired capacity is, and then we're going to make a to-do that says write this code. You tell it how big you need it to be, and it will make sure that it can handle that. Right? Now that's a very interesting method, but for the moment we're just going to leave it stubbed out and put a thing here that says, yeah, we got something to do later. Okay? By the way, that's my little notation to say before I turn in this code, go search for all the to-dos and make sure that you fill them in. Okay, so let's see now. So when we go to add something, what do we need to make sure that we have room for? Let's actually write up here, right? What do we need to make sure that there's room for? Well, we need to ensure capacity, but for what? Well, right now we know we're managing size number of elements, however many that happens to be, and we're about to add one more, right? So we need to make sure that we have enough capacity for size plus 1, right? Ensure capacity is going to take care of that, the magic of which we don't know, but it's going to take care of that, right? So for the add method, all I need to do is make sure I got room, right? And then I need to add that item, so element data, and it's going to go where? Well, it's going to go exactly at the sizeth position, right? And it's going to be set to whatever element they passed in. They pass us in 17. We're going to set 17 into the sizeth element. And then what are we going to do? We're going to increment size, right? Now, you may know that you could actually do this here, right? Do you know this? Right? We can actually do that incrementing there because remember, if you put the plus plus after it, it's going to increase it after it is consumed in this expression, which is fine, right? It's going to increment it after it's already used it to figure out where to put this element. So that's a perfectly good thing to do. Remember, if you wanted it to go before, you can do this plus plus size, right? That would increment it before it's used in the expression, but if we put it here, it will increment it after it's used in the expression, which is perfectly good, and then we're going to say true. Now, in this case, we're just saying true because we're incrementing it by 1. There may be some cases, and even here, it may be that that array allocation fails. right? And so we may, in truth, want to return true or false depending on something that maybe we have to try catch this array thing. Because as we're going to see, actually this ensure capacity is going to have to increase the size of the array, and depending on where we are, it is potentially possible that we could run out of memory. So there may be still some work to do here, or we may just not come back to that. But that's the idea of why some of these things return Booleans, is that sometimes they can actually fail. Right? All right, so that's a really good start to adding, and so technically our main should now run, right? If we come here and we compile main and we run, can we go and get out items? Well, we can't get out items, but we can ask it the size, right? So if I do this and I say, right, if I run this, I say it says size equals 4, right? Yep, sure enough. Well, so let's write a couple of the kind of obvious ones, like get is pretty straightforward, right? Get is pretty straightforward. Let's go do that. So if they want to get an element, what do we have to do? Well, one of the things that we're going to find out here, think about the fact that since we are now managing this variable called size, and the user, the client code, doesn't have any idea about this capacity thing, they could ask us for things that are outside the range of size but inside the range of capacity, and that wouldn't be an index error, but it would be illegal from our perspective, right? It's not something that we want them to do. So when they ask us to get something, we're going to have to check it, right, to make sure it's within our bounds, right? Because Java can't check our size, it's going to check its capacity on the array, but we need to make them believe that size is the thing here. So there's going to be one more method that we're going to have to do here, and that's going to be private void check index. And we're going to let them give us the index that they're looking at, right? That we are looking at. We're making it private, so this is for us. And we're going to say if index is less than 0 or index is greater than or equal to size, then we're going to throw, guess what? Oops, throw new illegal argument exception, and we're going to say invalid index must be 0 to size minus 1, right? That's what they can see, right? So they need to make sure that it's 0 to size minus 1, right? It has to be less than that. Okay, so now we can use this check index function on any of these things like get. So we can simply say check index, index. And if that's out of range, they're going to get the exception, which is perfectly good. But if it's in range, then we know we can just give back whatever it is that they need, which in this case is going to be element data bracket index. Okay. So some of these methods are darn simple, right? Darn simple. So now we can go to main, and we can actually not only prove that we can get the size, but we can say system.out.println element 0 or element 1 is, and then we can say plus myints.get, right? And it's going to say, here's our autocomplete's already working for us, and we're going to say get 1, and then that will tell us what element 1 is, and if we run that, we're going to see that it works. All right, so really coming along very well. How about set? Right? Can we do that one while we're here? Yeah, why not? Notice it returns an integer because what it says is, hey, you're telling me what index to set the thing to, but in case you didn't know what it was that was there before, I'm going to return that to you, right? So this is used as a, hey, yeah, just in case you care, just in case you weren't paying attention to what was there, I'm going to give back to you the value that was there because you gave me an index, right? So you might not have known the value. So what do you have to do for set? Well, same as before. We're going to do check index, make sure that that's a valid thing, right? Then we're going to remember the thing that needs to be returned, which is the thing at that position in the array, right? Then we're going to set the thing at that position to the thing they told us, right? So remember the old thing in this variable, set that thing to this thing, right, which is what they asked us to do, and then we're going to return element. Okay, easy enough. So a lot of these methods are pretty darn straightforward. They kind of write themselves, right? Which other ones can we do very easily? How about isEmpty? What's the easy thing here? This is so good, right? What do we have to do to decide whether the thing's empty? We just return whether or not size is 0, right? If size is 0, it's empty. If it's not, it's not. So we just return that. That's some Boolean Zen and awfully easy. Clear is the easiest thing ever. What do we do when we want to clear the particular array list, right? What do we have to do to make that happen? Well, couldn't be a lot easier. All we have to do is say size equals 0. But wait, don't we have to zero out all those places in the array? Nope. We don't care. We're not going to use them anyway. They can't look at them. We're not using them. We'll write over them as we increase size. So literally all we have to do is set size to 0. So far, everything is darn easy, right? The things that we need to do next, we need to think about adding and removing and what the implications are. You can see, I think, that index of and contains are not going to be particularly interesting. We're just going to have to go through the array until we find the thing of interest, right? But add and remove are going to take some thought, and the video is already getting a little bit long, so I think we should pause there. Stop this video. We'll come back and work on add and remove in the next video, but our array list code is coming along pretty good working with integers. So thanks for watching this video, and see you back in the next, hopefully.